Good afternoon, everyone. Welcome to the Construct Innovate webinar series on sustainability planning and construction. My name is Jamie Goggins, and I'm Director of Construct Innovate, which is Ireland's National Research Centre for Construction Technology and Innovation. This is a seven-part series, and this week we're going to concentrate on building envelopes, which are key to achieving low energy, healthy buildings. So as I said, it's part of a seven-part series. In there, where the last two webinars are also available online. So if you go onto the Construct Innovate website, you will find the previously recording from the other webinars. This webinar has been recorded, except the Q&A session at the very end is not being recorded. So we've got three presenters. Joe Fitzgerald, who's Technical Specification Manager from the Ecological Building Systems, and he's going to speak about the role of natural materials to achieving true ZEB, so zero energy buildings. Then we have Ceylin, who's a postgraduate researcher in Construct Innovate at the University of Galway, and she's going to talk about the roles of building membranes in high-performance building envelopes, which are effectively invisible shields for modern buildings. And then we have Dr. Harrison Ikhumhen, who's a postdoctoral researcher who's working with both GLF Facades and the University of Galway, and he's been developing an environmental, social, and governance methodology for construction industry. So each of our presenters is going to present for about 15 minutes each, and then we'll follow up with Q&A at the very end. So we'll have a Q&A session at the very end. If you have any questions for any of our presenters during their presentations or afterwards, please do post them in the Q&A function at the bottom of the screen. So you should find the Q&A function at the bottom of your screen. So please post your questions there. And as I said, we will deal with all the questions at the very end of the three presentations. So without further ado, I'm going to hand over to our first speaker, Joe Fitzgerald, who's a Technical Specification Manager in the Ecological Building Systems, who'll talk about the role of natural materials achieving true ZEB. So over to you, Joe.
Yeah, thanks for that introduction and for inviting me to speak today. We're going to look a little bit past operational energy in my presentation. We're going to look at how the natural fiber type insulations that find their way into passive house sometimes can play a role in the other side of the equation, the embodied energy side of things. So I'm not going to stop for long here. I'm with the company since 2017, and my role is within the technical team of our company, which sells a lot of natural fiber products, and many of them of which are imported into the country. So from that, we then have challenges to technically support these products and grow them within the Irish and UK market context. So for this presentation, and in the context, as I said, of true zero energy buildings, we need to go beyond operational performance. So we take a look at a commercial project and a domestic project, and have used the same build methodology to outperform both operational and embodied performance, far exceeding the target values shown in this table on the screen, which is just a reference table for the RIAI 2030 climate challenge targets. What I like about this little table is that it gives it gives a dwelling example and it gives a school example. So what we're going to look at is the embodied carbon part of those tables. So for the dwellings trying to stay below 625 and for schools trying to stay below 540, we're just going to put it into context. So for two projects that basically built from the same method, here's a concept that we've developed in Ecological Building Systems. It's just based on sound timber frame principles, good thermal design, and natural fiber insulations. So it's roof and wall systems that have flexible wood fibers or blown wood fibers or blown cellulose or grass-based insulation or sheet wool between the main frame. And then you've got a secondary dense wood fiber insulation outside the frame, beating all the thermal bridges in the building, and an insulated surface cavity internally, and then standard internal finishes like gypsum boards with paints and plasters, etc. So it's not an overly challenging way to build. It's a very intuitive way to build a timber frame, and it performs very, very well. So this concept is based on resource efficient construction technology, and it combines the benefits of using a primary insulation space for good U values with a continuous layer of insulation on the outside for thermal bridge free design with better thermal mass for timber frames. So this first example I'm going to show is one of Leiden Design's early projects, where they kind of started small with a 200 square meter school, and they smashed their RIAI targets out of the water. In fact, they bet them by nearly 54% lower than the 2030 targets for new schools when it comes to carbon in new schools. So Leiden are fast becoming known, as well as many other really good MMC-based contractors. They're fast becoming known and getting a reputation for this type of ultra-low carbon, all-timber turnkey projects. So they scaled it up in this project by a factor of 5 because they'd done well with a 200 square meter school. They built a 1,000 square meter school down in Offaly, and essentially they built it the same way. They built it with timber frame, they've insulated it with cellulose, and they put wood fiber on the outer side of the cellulose. Now, other design decisions can affect the embodied carbon within the building. For example, the type of cladding you choose. Open jointed facade is obviously lower carbon than plastered blockwork, for example. So some of the decisions were out of their hands. And in this particular project, 1/3 of the emissions actually came from the concrete foundation. So the entire superstructure, which has been insulated with blown natural recycled newspaper and dense wood fiber boards that are upcycled wood chippings that are otherwise a waste material from the production of sawmills, etc., on the continent. The majority of carbon stored in this building is actually in the concrete frame, or produced in this building is actually from the concrete frame. So they've had this project independently analysed by John Butler in the UK. So he's a whole life carbon consultant. And some of these results were published in Passive House Plus magazine, one of their earlier copies from maybe 2 years ago. And what was clear was that the as-built in combined carbon contained within this building, excluding foundations, was much, much less than the actual as-built with the foundations involved. So a big, huge chunk of carbon in this building is associated with the foundations, which they had nothing to do with. So the concrete was really what was weighing them down. But despite this, they still smashed their RIAI carbon targets. So we know that it works for a commercial context. It's way below the RIAI climate challenge target values. So the question then is, if it's that scalable in one way, can it also be used for domestic projects, one-offs, schemes, etc.? So for this purpose, we're going to look at the Larween Passive House. This is quite a well-publicised passive house at this point. It's my colleague Niall Crossan's own home. And in a domestic context, this is also a naturally insulated timber frame built to passive house standards. And it really shows that the combination of good design, like passive standard of design, combined with material selection, is all we really need to achieve true zero energy buildings. So Niall wanted to build a passive house, a certified passive house. And as a company who's been importing and supplying the Irish market with wood fibre, sheep wool, cellulose, and a range of other natural fibre insulations for over 25 years, Niall really wanted to build this house as low carbon as possible. So Niall insulated his home with blown wood fibre between his timber frame studs. He insulated the outside of his timber frame studs with an 80mm dense wood fibre board from Gutex, roof and walls. He then used a certified P5 racking board on the inside of his frame and a 50mm surface cavity filled with sheep wool. So that's the basics of Niall's construction, roof and walls in this building. Now, the reason Niall's house performs so well really is because of good design principles, not just good U values and what he's built from. But in this predicted annual heating cost that I developed for Niall back in 2019, I was looking at the internal volume of his home, the U values that he had, the type of windows that he had, the type of heating system that he was going to run with, and then some space heating data from his area, the degree day information, location specific. And I was able to give a kind of a crude, rudimentary prediction of what he might spend in terms of heating annually, just based on those factors alone. And on the left-hand side of the graph, on the green side of the graph, based on an airtight result being achieved of 0.4, I was predicting that he might have to spend around €330 annually on his heat pump, just to run his heat pump. And then the leakier he made his building all the way up to current building regulation standards, it was likely that that was going to multiply. So the amount of money he'd have to put into heating was going to multiply depending on how leakier the house got. Now, in Passive House, it's well known for not having too many performance gaps. But what was really pleasing about Niall's house was last year, I was able to get Niall's energy bills from him. And from his energy bills from 2024, the predicted consumption was only 8% off what I predicted compared with the actual build information. So I was predicting €328 annually. In fact, he was only spending €302 annually based on the breakdown of his energy bills. So the performance gap is, I often absent when it comes to good passive design principles. And then, of course, when you're scraping the bottom of the operational barrel like that, you really want to get the embodied side of things right. So what's even more pleasing about a house built like this, of course, is that it actually performs in reality. So this is just some observations that were made since Niall has moved into his house. But during the 2025 winter power outage, the solar gains in Niall's house for nearly 18 days kept his building above 19 degrees C. So that entire area that Niall lives in, the rolling hills of Cavan, was without power for a number of weeks. And Niall was the only man in the country going around in a t-shirt inside his home during that time. So his house really performs, not just predicted or on paper, but in reality as well. Good passive principles lead to warmer homes. So when it comes to passive house, of course, he delivered on all fronts and he smashed his targets. And then when it came to the embodied carbon in his building, we had to look at external experts. So we employed Wayne Moorhead Architects, John Moorhead and Shane Fenton to take a look at this for us. And just based on, you know, setting some carbon limits like our target of 625 for domestic carbon target, and looking at scales like the London Energy I can't even think of a Letty scale. It's like an A rating scale for the carbon performance of buildings. If you look at some metrics like this, you can get an idea of how Niall's house performed. And they determined that Niall's house was approximately A rated, with some really, really high performance results, much better than the REBA or RAI climate challenge targets. So he smashed his embodied targets, but with it being A rated, the question came up, why wasn't it A plus or A plus plus? But we also got some good useful information out of this exercise, which was of course independently calculated. And we were able to determine just some comparisons from some other building types. By going with passive house built from timber frame, instead of passive house built from block or ICF or other forms of construction, it's quite clear that the upfront carbon involved is much, much less. In fact, it's about half that of ICF, but ICF could be half that of a different construction type. So it's not to say one type of construction is better than another. There's always savings to be made, which is something I hope to show as the slides go on. So just in a simple graphical form, looking at the upfront carbon in the wall types alone, not considering any other building specific elements like things that might go naturally with a cavity wall, for example. You might have concrete hollow core flooring, or you might have precast concrete stairs. You might have some steel, you know, so the type of construction can also lead to more energy intensive components within the construction as well. But this is just looking at walls alone. But so it's clear from this project that the built variant is about half the cavity wall variant and about 33% of the ICF variant, which is quite significant. So then back to the question, how would he move from A to A plus or A plus plus? And really it's just looking at the materials that he used to also finish the building and the things he surrounded himself with, or to go back to Leiden's initial issue, maybe looking at the concrete first in the ground. So in Niall's house, he used a core passive raft foundation system. And these coloured squares are just an indication of where the carbon lies in his building, with a big square being a big chunk of carbon. So as you can see, external walls, big chunk of carbon, substructure, big chunk of carbon, that's his foundation, and then his roof. Okay, so let's just look at the substructure alone. Had he opted for concrete that had 50% GGBS in it, and we ran the calculation again, he could drop his embodied total equivalent to the 2 years of operational energy, or driving an electric car 60,000 kilometers. So that's an improvement Niall could make. So also if he changed his substructure plus his external wall, instead of using a block on the outside of some of his building, which he had to do, if he opted for a rendered cement board in lieu of that block, he could really reduce the embodied carbon within the wall dramatically, equivalent to saving up to 6 years operational energy or driving an electric car 185,000 kilometers. So by combining both of those improvements, of course, it leads to an even better overall energy saving and upfront carbon saving. But it's just proof that even with good design principles and using very low carbon natural alternatives to synthetic everyday type of products, there's still improvements that can be made across the board, right down to the type of paint you use and the light fixings within the house. So I think I'm just a tiny bit over time, and thanks for listening.
Brilliant. Thanks, Joe. This is a great presentation to, I suppose first showing the school projects that can be done in schools, but then going into more detail in the residential building. And I'd say Niall could probably make a few quid to help pay back some of his costs by charging people to visit his house in there during the construction of it and afterwards. But it just shows what can be done with, very careful design and consideration from the early stage, both in terms of the overall building, the layout and that, but also how it's constructed as well in there. And if you come at it from an earlier stage, you can get really good returns out of it, and really impressive the low embodied carbon values, but also obviously just showing how you could do even more in there. And I know, for example, with the external wall using blockwork, that there is a move to be able to use potentially use other range string cladding systems other than blockwork, which obviously can not just reduce the embodied carbon, but also can help speed up the construction process as well, because you can get more of it manufactured in the factory. So if anyone has any questions for Joe, then please do put them in the Q&A function at the bottom of the screen, and we'll deal with all those at the very end. So our next presentation is Ceylin. So Ceylin is now going to talk about the membrane. So we've talked about, Joe kind of focused mainly on the insulation materials and the wall build up. Now Ceylin is going to talk about the membranes in there, and basically to achieve those high air tightness. So Joe showed you can go anywhere between less than 0.4 in there for kind of passive house, or up to 5 air changes per hour, which would still meet the building regulations at 5. Ceylin now is going to talk through how we can actually achieve those high air tightness performances. So over to you, Ceylin.
Can you see my screen now?
Perfect.
Okay, hi everyone, and thank you for joining today. I'm Ceylin, a PhD researcher at the University of Galway. Today I will talk about the role of building membranes in achieving high performance building envelopes. So there are lots of the impacts we need to consider building envelope. Those are structural stability, hygrothermal barrier, air tightness, weather issues, acoustics, durability, and energy. But before focusing specifically on the membranes, I would like to briefly highlight the overall role of the building envelope in the modern construction. So the building envelope is basically like a skin of the building, and it separates indoors from the outdoors. It's not just about the wall or roofs, it's about keeping the inside space stable and comfortable as well. What's the role of building membranes here? Air tightness, durability, and energy is a key parameters for the building membranes in the buildings. So like air tightness, it provides stopping drafts and leaks that waste energy. And then there's a durability. That's because the envelope is exposed to everyday sun, wind, and rain. It needs to last. And of course, energy. A good envelope reduces heat loss in winter and heat gain in summer, which means less energy use. So in short, if the envelope works well, the building feels comfortable and the cost less to run. It's like a chain and performs better overall. Let me explain you briefly storyline of the membranes, how it's working inside of the wall. You'll see the airtight vapor control membrane were placed just behind the internal lining. The vapor control or airtight membrane, that role stop indoor air and the moisture from leaking into the wall structure. So think of is a seal that locks comfort and energy inside. The middle of the wall, you see the insulation layer that keeps heat in during in winter and out during in summer. So it's like a protecting by membranes on both sides, so stays effective over time. So the last one is the breather membrane, were located behind the external cladding. The breather membrane role let trapped moisture escape from the wall, but block rain and wind from entering. You can think about like a raincoat. It's like a protection without trapping dampness. Together frame, the airtight membranes keeps conditioned indoor air in, and the breather membrane keeps weather out while allowing drying. And this duo extends durability, reduces energy loss, and prevents mold or condensation issues. So here we can actually see the microstructure of the membranes. The breather membrane looks more open. You can see the little gaps and voids. That means allows vapor to pass through while still blocking rain and wind. On the other hand, the airtight membrane is much denser and layered, fewer gaps, which means it blocks both airflow and the vapor diffusion, creating a tight seal. When we put them on the real buildings, as it in image is a partial application in the sites, you can see how they work together, one inside and one outside, keeping the structure dry, protected, and efficient. Here we can see what happens when the membranes fail. The left one is a one of the most common fails in the building membranes. It's like a damaged. It can't do its job of keeping air and the water. The middle one is also mold and dampness indoors that leads to unhealthy buildings. So the right one is a water damage inside the wall, insulation gets well, and structure begins to rot and energy performance drop. When the membranes fail, the whole building suffers from comfort to health to durability. It's like a chain. Usually membranes performance is checked in the three main areas. The first is durability. Tests like tensile, tear, and pier are used. That shows how much force a membrane can handle for its stretches, tears, or loses strength. The second one is a hygrothermal performance. This is about how the material deals with moisture and water, and the test check if vapor can pass through when needed while also blocking water from getting in. A third one is environmental performance. Membranes are exposed to real outdoor conditions, or sometimes lab tests are used to speed up this aging process. This is accelerating aging test. This helps see how they hold up under sun, rain, wind, and the temperature changes. To put together this, all the key performance metrics give to us to see bigger picture, how strong a membrane is, or how it manages moisture, or how well it lasts over time. So here are flow of key performance that we test we run in the lab right now. I am working on my PhD as well. I'm doing these tests. This is a collaboration project between Partel and the Construct Innovate. So the first of all, we are doing the durability performance, tensile test, tear test, and the peel test. Actually, this shows how strong the membrane is, how much it can stretch or resist ripping, and how well tapes bond to it. So then hygrothermal performance, we run water vapor transmission tests, usually taking around 6 to 10 hours based on the standards, and depends on the product as well. So, and the waterproof test where membranes are put under the pressure for 2 hours to see any leakage happens. So all the tests are running right now in the lab based on the international standards. The last one is environmental performance. Actually, it's running in the 5 locations in my PhD project right now. And in the parallel, we do accelerating aging tests in the lab using UV, heat, and the moisture to simulate months or even years of exposure in a shorter time. Together, these tests give us complete picture like a strength, moisture control, and how membranes hold up over time in both laboratory and real world conditions. This is tensile test. Let me explain you briefly. The membrane samples is clamped between the upper and lower grips. The machine then pulls the grips apart, applying the steadily increasing force, and the force rises. We measure how much the material stretches before it breaks. The graph, we can also monitor the membrane performance during the test on the screens, and these results show that strength, elongation, and breaking points of the sample. So these are the setups we use for aging tests. The left one is UV aging machine. It exposes samples to strong UV light, simulating solar radiation. It's just a few weeks. The right one is environmental test chamber. Here we can control the temperature and humidity to see how membranes react under heat, cold, and moisture as well. The left one is a waterproof test. The membranes is placed under the pressure with the water on top. If it holds for the full test time without leaking, we said the test has passed. If we see any leakage like an indicator, we said test has failed. On the right side, we can see water vapor transmission test. Samples are sealed over a dry cup method with the water inside, then placed in a controlled environment. And the overall hours, we measure how much vapor moves through the membrane. Together, these two tests show the balance, like a good membrane blocks liquid water, but still allows vapor to escape. Here I'm showing some results from my project, like a tensile test, which is one of the key evaluations for membrane durability. These tests, as I mentioned before, were conducted in line with the international standards. And here we compared membrane 1 and membrane 4. The membrane 1 is a thermoplastic, like a fiber-based material, and the membrane 4 is an eco-based version of membrane 1. The purpose of this test is to understand how much mechanical force a membrane can handle before it fails, and how that contributes to energy absorption capacity and overall structural reliability. Let me see in the graphs. Membrane 1 shows which failed around 450 and 500 Newton, while membranes 4, this is an eco-based performance, reach up 800 Newton. This is a significant improvement due to reinforced eco-based design. And that our results show that the eco version, all the paper-based performance even stronger in the tensile testing and contribute to sustainable building construction. This is a waterproof test. We are using protecting insulation and the structure from water damage. These tests can check the performance against building standards. And also it runs, they ensure reliability, durability, and safer, more efficient buildings. There are lots of the steps here, and like indicator chemicals, it's like a pool fill up with the chemical, and then membrane product we are placing, and filter paper, glazing, and setup. So this slide shows the aging studies, which are the key part of my PhD, actually. At the top one is a site aging test. The site aging rigs in the different locations, like Galway, Toronto, and Colorado as well. These tell us how membranes actually perform in practice. At the bottom one, we have accelerating aging test in the lab. You can see how the membranes change from the initial state to after 336 hours and then 672 hours of the UV exposure. These two approaches, both field and the lab test, give us the full picture, long-term durability. And honestly, this is one of the most exciting part of my research, because we are now waiting to see how these membranes evolve over time and what that means for membrane reliability in the buildings. So for the wrap up, the membranes every time may be hidden, but they play a huge role in buildings, and they protect against leaks and molds, but improve comfort and reduce the energy use. For the industry, this means longer-lasting, eco-based solutions that cut costs and support sustainable construction. And scientifically, combining lab and field testing helps us define durability limits and guide better choices for the future. Thanks for listening to me.
Brilliant. Thanks, Ceylin, and great introduction to membranes and the importance of membranes, but also the different types of membranes and how they work. And then nice to see the actual hard work that goes into the background in terms of testing to make sure that these are fit for purpose to be used in the industry as well. So if anyone has any questions for Ceylin, please do post them in the Q&A function at the bottom of the screen, and we'll, as I said, we'll deal with all those questions at the very end. So further ado, I'm going to move on to our third presenter. So Harrison is going to talk about his work where he's developing a environmental, social and governance methodology for the construction industry, or ESG as it is better known within the sector. So over to you, Harrison.
Okay, so my name is Harrison, and today I'll be giving a presentation about our project which we're working on. It's about developing an ESG methodology for construction industry. So like we all know, the issue the world is actually facing today is the issue of climate change, and so to mitigate this particular issue, so a series of world leaders came together to establish the Paris Agreement with the primary goal of limiting the temperature rise well below 2 degrees Celsius. So this also gave birth to the adoption of series of like regulations like the EU Green Deal, with the primary goal of like reducing emissions by 55% by 2030 and net zero by 2050. So Ireland, on the other hand, has also like come up with like series of regulations as well, like the climate law and the National Irish Climate Action Plan. So how does the construction industry actually come to play? And so construction industry are actually known to be one of the major contributors to this greenhouse gas emission, which with over 1/3 of the global emission being contributed by the construction firm, 40% of which are from like the energy consumption, and 1/3 of the global resource use. So, and then the sources of all of these emissions are also like being known to be from the direct emissions, indirect emissions, and operational emissions. So on one way, construction industries can actually, or other industries as well, can ensure they have like a sustainable practice into, and forge the path towards decarbonization is the integration of like ESG into their practices. So that brings us down to the question about what is ESG. So this is actually basically, ESG is actually a framework which actually helps construction firms or other companies to measure their performances and impacts with regards to like environments, which with key emphasis on like the impacts on climate change, biodiversity, energy use, and so on. And then with the social, it's actually basically about the social impact on the people, the communities, the supply chain, and also the diversity and inclusivity. And then for the governance, it's actually looking into like the transparency of the company, the corporate governance structure, and then the ethical business practices. So why is this ESG actually critical for construction industries? This is actually because like adopting ESG into your practices helps these companies to actually track, report, and improve their carbon performances, aligning with like the national and the international climate goals. It also helps the companies to strengthen their health, safety, and management system, fostering a culture of safety and responsibility. It helps to protect the life and also promotes the well-being of their employees. It also helps the company to promote the ethical sourcing, supply audits, labor rights, and fair procurement, while mitigating the risk of exploitation, modern slavery, and unsustainable practice across the value chain. And most of all, like it helps the company to ensure compliance with regulations. And what do I mean by this? Like it's also not just about the climate regulations, but also on the ESG regulations, like the EU CSRD, which actually mandates companies to have their ESG reported, like especially the large companies in the non-disclosure the non-financial disclosure regulations to actually have their ESG reported by 2025 and other large enterprises and SMEs by 2027. So and in doing this like this, companies are actually going to actually meet expectations from our clients, investors, and financial and also communities on their ESG performances, and also to actually avoid market exclusion, reputational damage, and financial penalties on ESG shortcomings. So the objective of our study was actually basically based on the fact that adopting ESG can be found to be quite complex and complicated for most industries. So we decided to come up with a simplified methodology, which is actually practical and actionable framework, which can be easily applicable to the industry. So this will also help the companies in tracking and also monitoring their and reporting their ESG performances. At the same time, also support their decision-making process, making policy, and then also like aiding in their policy generation. And all of this will also aid the company to actually demonstrate their commitment towards like this ESG and sustainability. So then to actually conduct this study, we actually went through a series of like steps. So first of all, we conducted like a state-of-the-art literature review and policy review on all of these policies, which also intertwined or interlinked with like the adoption of ESG into the practices. And then we went on to actually review public data of top 50 Irish construction industries to actually get an understanding of like to learn about the ESG adoption rates and also like the practices. So we then went in to conduct a semi-structured interview. So all of this review aided us in actually identifying like the best practices and identifying like 27 ESG KPIs. So after the identification of these KPIs, we then went into develop a methodology of these identified KPIs. And then using like, because I'm currently working at GLF under a project from the Construction Innovate University of Galway. So we're demonstrating this methodology with the facade specialist, which is GLF at the moment. So based on the industry review and the structured, semi-structured interview conducted, we noticed like the adoption rate of like the 27 identified KPIs. We have noticed that there was like 65% adoption rate of this, which was actually mainly influenced by the large enterprises. The SMEs and the micro enterprises actually fell short in the adoption of most of all of these KPIs. And then based on the outcome of the survey we actually conducted, we found out like it was for the environmental pillar, most of the companies actually mainly focused on the carbon footprint measurements, which also include waste management, energy conservation, and biodiversity conservation. So the other widely adopted KPI was with regards to the social pillar was the health, safety, and well-being. This is actually because it's a construction firm, and then the companies actually take priority with ensuring the safety and well-being of their employees. The other widely adopted social pillar was learning and development, community engagement, and gender equity and inclusion. In regards to the governance pillar, the widely adopted pillar was the regulatory compliance. So others was like stakeholder engagement and ethical culture. So based on the overall review we actually conducted, so we kind of like designed a methodology, or rather we proposed a methodology which could be adoptable to like some companies, especially the SMEs and the micro enterprises. And these steps actually, based on the proposed methodology, which what could be followed to actually ensure the companies actually demonstrate their ESG performances in their practices. So one of them is the definition of like ESG policy. So this will actually be followed by the identification of KPIs. This means that the company needs to actually select based on the 27 identified KPIs we actually selected from our survey. So companies can select KPIs which is relevant to their operations. And then this will be followed by the measurement of these ESG KPIs using the Excel toolkit, because using all of these these 27 KPIs we developed in the Excel toolkit, which could aid company in actually imputing their metrics and also measure and assess their ESG performance. And then this will then be followed by the establishment of a baseline. Like if, like for instance, 2025 is just the year you actually commencing your sustainability practice or your ESG performance record reporting. So you may establish that as your base year, and then this will be followed by an annual tracking and monitoring of your performance. And then this outcome of all of these performances will actually be used towards like the development of your ESG report and disclosure. So this process needs to be continued. It needs to be a continuous process. So it's a circular process which should be done annually with your outcome of each year compared with your baseline year to actually determine how well you're actually doing with regards to the ESG integration in your company. So, and then like with the Excel toolkit I mentioned earlier, so we developed an Excel toolkit so easily assess this toolkit. So companies will actually follow this series of steps. So first of all, you're going to actually select the relevant KPIs to your organizations from the 27 identified KPIs from our studies. And then you then want to go on to collect your data, which could be from your utility bills, procurement records, your social activity records, employees engagement records, etc., from different designated departments in your organizations. And then you then go into actually impute the values from your data recorded, you assign value to each of them, and on if needed, you could actually rate most of this information as regards to each of the KPIs to assess the performance. And then you analyze, which means you actually compare your results with your company operations and your standards. And lastly, based on the overall outcome you actually get, you then go on to prepare your ESG reports. So this is actually the Excel toolkit we actually developed. Like this is, so after imputing your information into the Excel toolkit, then the toolkit actually generates like a dashboard which automatically visually represents your data, which is actually imputed into the toolkit. So this is actually an example of the dashboard. This is for the environmental KPI. So when you impute all of them, so it automatically helps you calculate your carbon footprint. If, for instance, you are measuring your waste management, for instance. So when you impute your waste generated in your organization or your company, so you impute the weight of the waste and then the category, the waste type. So it automatically generates the proportion of like the different types of waste, be it compost, recovered waste, recycling. So it automatically computes the proportion of that and also helps you to calculate the emission of the waste generated in your company. So similar approach also applies to the social KPI. So when you input your data with regards to that, so it automatically displays in your dashboard. Like for instance, we have like the health and safety and well-being. So for instance, you have like the number of annual emergency drill actually conducted. So you actually put in the digits in the toolkit, and then it actually comes out in your dashboard. So actually gives you a visual representation of like what you're doing in your organization with regards to that. And then if you actually don't have records in that, it could also be displayed there to actually gives you like an information about how you could actually areas of improvement for that area. And then for the governance as well, similar approaches also applied with each of the KPIs actually being identified. So you impute your data in there, and then the dashboard visually displays that for you to actually pinpoint the information which is actually needed for your ESG reporting. So this will show you a sample of that for like the governance KPI, like risk monitoring and assessment, for instance. So we have like, so if you impute the information, it automatically gives you like a chart of like the risk identified in your organization. And then also like, if you're actually mitigating the risk, it tells you like the percentage of the research that's being mitigated. So to summarize it all, like, so this overall research is basically to actually develop a methodology, a simple and simplified methodology, which is actually to help company to actually assess their ESG performances with regards to your company operations. And then this also ensures like doing this, you also ensure that you're actually in compliance with like series of like national and EU regulations, like the climate regulations, the ESG regulations, and all the sustainability regulations and standards. So in doing this, it also helps the company to, reduce your operational, reputational, and climate-related risk while strengthening your company's resilience. And lastly, it also like helps to build or improve your company's competitive advantage by improving your tendering success, investors' confidence, and also stakeholders' trust. This is also because like in some cases when you're actually tendering, there's also the issue of like where some stakeholders or some investors actually require companies to all have this ESG reporting. So by adopting all of this or using this particular methodology, companies could easily come up with like some ESG reports and some disclosure on how well they're doing with regards to that. So thank you. That's all my presentation.
Brilliant. Thanks, Harrison. A great overview of the ESG and the toolkit that you've developed in that for companies, and we can see, you know, how important this is. Obviously, it's been very important for a lot of companies, not just reporting the ESG annually, but also making strategies around improving their environmental, social, and governance within their organizations. But we can see now with the way legislation is going, the requirement for the large companies, and then coming soon down the track for SMEs to do this, and obviously having toolkits like your own to make it easier for companies to implement their ESG policies and practices is very, very important. So with that, just want to thank the three presenters, and now we'll open up to Q&A. So if anybody has